In the last section of Chapter 4, we are going to talk about inverse linear functions. So by the end of this lesson, you should be able to find the inverse of a relation and find the inverse of a linear function. So inverse relations are the set of ordered pairs obtained by exchanging the x-coordinates with the y-coordinates of each ordered pair in a relation. So if we start with something like 5, 3, then 3, 5 is the inverse. So we're exchanging x and y. X becomes y, and y becomes x. So if one relation contains the element AB, then the inverse relationship contains the element BA. If you look at all of these, all we did was switch this around. Notice that the domain of a relation becomes the range of its inverse, and the range of a relation becomes the domain of its inverse. So these blue ones here were all the domain, but in the inverse, they're the range. The red ones were the range, and then in the inverse, they became the domain. So find the inverse of each relation. So the first thing we got to do is take a look at all of our points, and we're just going to switch them around. So 8, negative 6 would be the inverse, 11, negative 15, 3, 9, and 6, 0. And that's it. This is the inverse of that. Same thing with this. Instead of having an x and a y like this, we're going to switch it around, and our inverse is going to become 5, negative 10, 11, negative 4, 12, negative 3, and 15, 0. And it's as easy as that. Now when we're looking at a graph, the graph is a little different, but remember graphs are made up of a bunch of points. So find some points on this graph. This one here is at 1, 2, 3, 4, up 2. So negative 4, 2 is going to become 2, negative 4. So if I graph that over 2, down 1, 2, 3, 4, that's a point. And then let's pick a different color. We'll find another point. This one right here is negative 1, 1. That becomes 1, negative 1. So find that point, over 1, down 1. Let's try another color. This point right here is at 2, 0. So my inverse would be 0, 2, right here. And that looks about good. We can see that my inverse line is just connecting these 3 dots right here. This is the inverse relation. That guy right there. So we can do the same thing over here. We'll choose some points. This one here is negative 1, 1. So it becomes 1, negative 1. All we got to do is switch it around. So over 1, down 1. Let's pick another point. How about this one? So that's over 2, up 2. The cool thing about this is when you switch it around, it's exactly the same, 2, 2. Let's find another point, or we could just connect those, because remember, all you need to make a line is 2 points. So this guy is your inverse. What you end up doing in order to find the inverse of a function is you flip it over the line y equals x. And remember, y equals x is starting at the origin, and the slope is 1. So it's this black line right here is the line y equals x. And if you look, if I took the original one and kind of like sandwiched the paper, this thing would come up here and this thing would go down there, and that's the inverse. Same thing with this. The line y equals x actually goes through that purple point, so that's why the purple point didn't have to move. But if I flip this over, this becomes that, and that becomes this. So, a linear relation that is described by a function has an inverse function that can generate ordered pairs with the inverse relation. So remember when we used f of x, the inverse is denoted like this. It's f with a little negative 1, but it's a superscript. And we read it as f of x inverse or the inverse of f of x. This is how I always say it. the inverse of f of x. So steps you need to find this. First thing you're going to do is replace f of x with y, because that'll just make your life easier. Then exchange x and y. So just like the points in the table and the graph, we're going to switch them around. Solve for your new y, and then replace it with f inverse x. So what we're going to do first is replace. We're going to switch. So we'll say replace, switch. So this becomes x equals 4y minus 12. And then we're going to solve. Remember, we want it to be y equals, so I'll add 12 to both sides. So 4y equals x plus 12. And then divide everything by 4. So we get y equals x over 4 plus 3. And then replace again. Whoa, what's going on? Replace. So instead of y, we want, what is going on right now? The inverse of the function is x divided by 4 plus 3. Not too bad. So we'll do the same thing with the next one. So your steps are the same. You start off replacing. Start off exchanging. And then you solve. So we'll subtract 7 from both sides. And then instead of multiplying by 1/3, I'll just multiply everything by 3. So I get y equals 3x minus 21. And then remember, instead of writing y, we'll write the inverse of f of x equals 3x minus 21. So let's try a story. Peggy rents a car for the day. The total cost, C of x, in dollars is given by C of x equals $19.99 plus 0.3x, where x is the number of miles she drives. So the first thing we have to do is find the inverse. So let's do the same thing we did before. Replace C of x with y. And then we're going to rearrange the x and the y to find the inverse. And then we want to get y by itself. So we'll subtract $19.99 from both sides. So we get x minus $19.99 equals 0.3y. Then we'll divide everything by 0.3. So we get y equals, this is kind of messy, but think of this as 1x. So if I do 1 divided by 0.3, we end up with 3.333. So that's what I'm going to use. And then if you do 19.99 divided by 0.3, we end up with 66.6. So then we'll change this to the inverse of C of x equals 3.3x plus 66.6. So there's part A. We found the inverse. So now let's answer the questions. It says, what do x and C, the inverse of C of x, represent in context of the inverse function? So remember, before, this was the cost, and this was the number of miles. So remember, an inverse switches things around. So now this is number of miles, and this is our cost. Whoops, both of these should be negative. Sorry about that. Change that to negative, because we had the minus 19.99. So when I look at C, and I want to know how many miles Peggy drove if her cost was $34.99, now that I know that x is the cost here, and that the inverse is the number of miles, all I got to do is plug this in, 34.99 minus 66.6, and then it's a calculator problem. And I end up with about 48.867, so we'll round it up to about 49 miles. So you have a couple to try on your own. Make sure you write down any questions you have, and we can go over them in class. Enjoy your night.